Hey guys, so we are about to do homework 6. We're going to do the very last question in the packet, which is question number 12. This was actually on the AP test last year, and a lot of the kids came back from the test and were so confused. So I just wanted to kind of go over it with you, make sure you guys got it. So it says the inside of a funnel of height 10 has circular cross sections as shown in the figure above. At height h, the radius of the funnel is given by r equals blah blah blah, where 0 less than or equal to h less than or equal to 10. The units of r and h are inches. Okay, part A. The average find the average value of the radius. So average value is one of your formulas. I'm going to do it up here to the side. So for part A, average value is 1 over b minus a integral a to b of f of x. So specifically here, if I want the average value, that's going to be the average of the radius. Now notice 0 to 10 is my height. So 1 over 10 minus 0, then integral 0 to 10, and then my function, which is 1 over 20, 3 plus h squared dh. So it's 1 over b minus a, integral a to b. Now, they do actually make you work it out, and you would not have had a calculator. So 1 over 10 minus 0 is a tenth. I'm also going to take this 20 to the outside, so it's a 1 over 20. Integral 0 to 10, and then when I notice that I have my 3 plus h in here, 3 plus h squared, that's going to be a really easy antiderivative. So let's do it. Antiderivative of 3 is 3h. Antiderivative of h squared is going to be h cubed with a third in the front. And then this number in the very front, if it's 1 over 20 times 1 over 10, that's really 1 over 200. Okay, and I'm just going to kind of leave that number out of the whole process. Then on the top I'm plugging in a 10, on the bottom I'm plugging in a 0. Now keep in mind that when I plug in 0 here and here, those are going to cross out. But when I plug in 10, I'm going to have 10 times 3 is 30, and then 10 cubed is 1,000, so that's actually a plus there, sorry. And then I'm going to have a third of 1,000. Now let's say for whatever reason that you didn't know what 10 cubed is, then you could have just written 10 cubed. Okay, then remember that I have this minus this, so it'd be 30 plus a third of 1,000, and then with a 1 over 200 in the front. And then remember, for part A, that's good enough, okay? All right, go down to part B. This is where people got confused. So part B says to find the volume of the tunnel, okay, or the funnel. I want you to think about if I want to find the volume, okay, each of these cross sections, it says, are circular. So that means that I need to integrate what this shape is, which is pi r squared. Okay, and then when I integrate my pi r squared, I'm going to integrate it across the domain, which is from 0 till 10. So this is basically a dy integral, but they did it kind of in a confusing way. So I would write volume equals pi integral 0 to 10, and then my r is this, but I have to square it. So it'll be 1 over 20, 3 plus h squared, squared dh. So it's pi r squared, and then we're integrating it to turn it from the area of this circle into volume. Now working this out by hand, we have to square the whole thing. So if I do 1 over 20 squared, that's going to turn into pi over 400, because I have 20 times 20 is 400. And then on the inside, for the 0 to 10, okay, now that I've taken that out of the way, I can't do u sub on this, so instead I'm going to just go ahead and expand it. So remember, it's square, double square. So I'm going to have my pi over 400 integral. Square would be 3 squared, which is 9. Double would be 6h squared. And then square, double, square would be h to the 4th dh. Then remember, endpoints are still 0 and 10. So I'm ready to take the antiderivative here. Pi over 400 in the front. Antiderivative of 9 is 9h. Antiderivative of h squared would be h cubed. Divide by 3 on the h, that's going to give us a 2 in the front. And then antiderivative there would have been 1/5 h to the 5th. Then from there, we're going to plug in 10 and 0. Okay, from there, plugging in 10 here, that's going to give me, I'm going to write my answer right down here. So I'll put part B continued. Okay, so when I plug in 10, I have my pi over 400 in the front. Okay, that'd be 90 plus 10 cubed, we said, is 1,000, so that'd be 2,000 plus, and then a 5th of, I'm going to leave that as 10 to the 5th. Okay, now keep in mind that when I plug in, I get stuff up here, what I just wrote, but on the bottom, I'm just going to get a 0. So that's why I'm not really going to go through and write top minus bottom, because my bottom, if it's 0, is really just going to go away. And then don't forget that that pi over 400 should still be there in the front. Okay? And then that would be your answer to part B. Okay, part C. The funnel contains a liquid that's draining from the bottom. At the instant when the height of the liquid is h equals 3, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. At this instant, what is the rate of change of the height of the liquid with respect to time? Okay, so I want you to think about first. They're using things like at the instant when liquid is decreasing at a rate of, all of these kinds of things we want to think about. This is really a related rate. So I'm going to set up my find, my given, and my when. Okay, so it says at the instant when the height of the liquid is 3, so h is 3. The radius of the surface is decreasing, so that's dr dt. So the rate that the radius is changing. And then if it's decreasing, then it's going to equal negative 1/5. So far, so good? Okay, then it says at this instant, what is the rate of change of the height of the liquid? So we are finding dh dt. Now notice, they've already given us the equation that relates r and h. So my equation for this one is going to be what they gave me. R equals 1/20, 3 plus h squared. Now, because this kind of looks like it's some sort of product rule, I'm going to go ahead and distribute before I take the derivative, just to make the rest of the problem easier. So 1/20 times 3 is 3/20. Plus 1/20 h squared. And now I'm going to take the derivative so that this isn't a product anymore, it's just like two regular terms. Okay, so the derivative of r is dr dt. And now that this is a constant, the derivative of a constant is 0. So that's going to go away. Okay, then over here I'm going to times my 2 down. 2 times 1/20 is 2/20. And then my h was squared, so now it's h to the 1. But then remember, because I'm taking the derivative with respect to time, I have to put a dh dt on the end. And then from there, pretty smooth sailing. dr dt is negative 1/5. This is going to reduce to 1/10. And then my h, it told me, is 3. So that'd be 3 squared dh dt. Okay, so that's really negative 1/5 equals 1/10 times 9, because 3 squared is 9, times 1/10 is 9/10 dh dt. And so then for my last step, to cross out that, I'm going to multiply by 10/9, 10/9. So 9/10 and 10/9 cross out, and then when I multiply these guys together, remember, it's straight across the top, straight across the bottom. So that's negative 10/45 dh dt. Okay, then I want you to consider that, then I want you to also consider that when you are working a related rate, if this comes out to be negative, that means whatever your quantity is decreasing. I want you to think about that if your thing is draining, and your dH/dt came out to be negative, does it make sense that your height is decreasing when the liquid is draining? Okay, of course that makes sense. But it's kind of a good thing to tie together, that as your liquid is draining, it makes sense my dH/dt came out to be negative, which implies it's decreasing. Okay, good luck. You can do it. See you guys tomorrow.